Okay, we're going to take a look at quadratic functions. So I'm going to try to give us a bit of an overview here of what they are. You guys have probably been shown y equals, and I'm going to try to use a couple colors here. It'll just be a little more helpful when we're going between them. So y equals a x squared plus bx plus the letter c. Have you guys seen this form of a quadratic before?
Yes.
Yeah. Okay, this is called the standard form. Okay. This is a very common form for a quadratic. The letters a, b, and c are usually represented by some numbers. A is a coefficient, b is a coefficient, and c is considered a constant. I'm going to put the other two up, and just like you may have learned in science when changing between solids to liquids, we're actually going to talk about how to change between these different forms of a quadratic. So another one you may have seen, y is equal to a x minus, how many colors can I get here? Oh, that's all right. Let's see if I can get another color. No, that's going to be too complex. Way too complex. I will just use blue. R minus S, we'll call it. This one's known as the factored form. And then finally, a third major form here, just for space's sake, I'll kind of drop it a little to the right. Y is equal to a x minus h squared plus, actually I usually use the h in blue, I think. Try to be consistent, k. And this one's known as the vertex form. Okay, so now that we have three of these written out, these are essentially the exact same equation. We've just represented them in different ways. So what we're going to quickly talk about, we're not going to go through all of those pieces today, but we'll talk about the processes of moving between them. Each of them is like a lesson in itself. But when we go from standard form to factored form, we use something called factoring. Okay, and I think we've talked a little about it in the past. I think you have too. And when you go from factored form back to standard form, it would be known as expanding, and then usually simplifying also. I don't know if I spelled that right. When we go from, and it's very common, the major form, think of this one being the major form here as your standard form, okay? When you go from standard form to vertex form, this process is usually called completing the square. And going back is actually the exact same process from before. It's also known as expanding and amplify. Actually, I think that is the right spelling. Flying. And then moving between vertex and factor form is a bit tricky. Essentially what we're doing is one of them is known as is finding a vertex, we'll call it. There isn't really a formal term for it, so finding a vertex. And then we're going to talk about why it is we're finding those things. And then to go from vertex to factor form is sometimes known as finding roots. Okay? And sometimes they go by different names, but these are essentially the processes. Think of this as like an overarching theme for quadratics that you're going to go through in this course. You're going to need to know all of these little things when going through quadratics. The one last thing I do want to talk about, just since this is like an overview, there we go. Just going to draw a little from standard form, so I'm going to call it SF. Y equals ax squared plus bx. The easiest one to grab information from, or the easiest piece of a quadratic to get information out of in standard form, is the c term, and that's actually known as the y-intercept. Okay, and we'll do a rough sketch after. I'll start it in the bottom left corner here. So the y-intercept, we'll say, the c value, if the c is a 5, so let's say c, for example, is 5, then we know it's going to cross the y-intercept at the value of 5. In factor form, so FF, y is equal to x minus r is important, and s actually. So we already actually kind of highlighted it too. What's important about these is the r and the s. These are the roots, and roots are also known as x-intercepts. Okay, so as x-intercepts, you might have an x-intercept here, and that's not going to work out perfectly for my drawing here. It's not going to look so nice. I'm going to move one of them over so it's a bit more realistic. X-intercepts. So I'm kind of setting them up here. Let's say one of the r's was, well, in this case, the value, for example, might be something like, it might say x minus 2 and x minus 5. And when they're in the brackets there, that negative sign's in front of it, so we actually pull them out. So I'm going to put the little x in front of it just so we know. It comes out as an opposite. So if it looks like x minus 2, it's actually positive 2. And if it says x minus 5, it would be positive 5. Okay, so I've given us some examples of what they'd look like on the graph in the bottom left corner. And finally, what you may guess, the vertex form is good for finding the vertex. Y is equal to minus this, because this is a negative again, h, we have a very similar concept to it, and then plus k. K is also important. H is the x value of the vertex is equal to h, we could say, and the y value of the vertex is equal to the k value. So in other words, let's say, for example, h was, again, let's say it said x. I'll give us a better example here. 3, it's probably 3.5. X was minus 3.5. That actually means the x value of the vertex, so let's say that was the bracket squared. X value of the vertex is actually positive 3.5. So it may be somewhere down here. And the y value of the vertex, we'll say, the k value was maybe negative 4, something like that. That means the y value, oh, that kind of jumped away from me, would be at negative 4. Let's just zoom in again. Okay, so when I go to kind of connect these, all of those pieces in the different form give us the information we need about a quadratic. We figure out the y-intercept, we figure out the two x-intercepts, and this is the vertex here. So each of those give us like a key piece of the puzzle that we're trying to solve.